Hi guys, what's up? So today would be the last part of trigonometry, heights and distances. So you must be wondering from the previous videos. Okay, so what if theta is 45 and it would be equal to this value? Okay, so now we are going to learn its practical application. So okay, let's just think about it. You know the tallest building in the world, Burj Khalifa, right? So it's around 850 meters, if I'm not wrong. Okay, how did they measure the height? They definitely couldn't have made a tape that big to measure its height. No, they used trigonometry to measure its height. Let me show you how. Okay, so as you may know, buildings are always perpendicular to the ground, except for the Leaning Tower of Pisa. That is obviously an exception. So just look around you. Look around at the buildings around you. They must be perpendicular to the ground or they must be straight up. Get it? Okay. So now let's see how this applies. So let's take this triangle ABC. Here AB can be a building since obviously it's perpendicular to the ground, and BC can be the ground since it's flat and below. So like you won't see any buildings floating in the air, would you? No, right? So they are always attached to the ground. So therefore BC is the ground. Okay. Now CA, what's the point of this? This is the most important part. This is what helped determine Burj Khalifa's height and other buildings' height as well. So this can be a rope, ladder, or even an imaginary line. Okay. So now let me explain a few details or a few technical terms. Okay, so now this theta over here, this is the angle of elevation. Okay, what do you understand by elevation? So by elevation you can think of it as high or going higher. Like the elevation of Mount Everest is 8,800 meters. The elevation of that building is 20 meters. So you can think of elevation as going up. So this angle of elevation is the angle going up. As you can see, it is facing up, right? So like because it's in between the hypotenuse and the base, it's going up. Okay, now depression. So depression you mostly associate with the feeling of feeling down or sad, and even in craters. The crater has the depth or depression of 30 meters. Okay, so depression means going down, and in this case looking down. Okay, so now this diagram is a little complicated. So let me explain all the terms. Again, AB is the building, BC is the ground, and CA can be the ladder, rope, or the imaginary line. Okay, now what is this dotted line and what is this angle? Okay, so now imagine okay, so you're just standing. Tell me, how do you look? Generally, how do you look? Like when you're just walking around. Do you look down like this? Do you look up? No, you look straight. So that's what. So when you're on top of a building, you would still look straight. You wouldn't look down or up. So this is the line of vision, meaning looking straight from the top of the building, mountain, whatever it is. Okay? And now, one interesting thing is, so as we know, the building is perpendicular to the base, correct? But also the angle, the line of sight is also perpendicular to the building. Because you're looking straight, right? And when you're looking straight, since the ground is also straight, let's assume it's straight, of course. So since the ground is straight and we are looking also straight, it forms two parallel lines. And because they are parallel, these two angles are supplementary or add up to 180 degrees. So since this is 90 degrees, this should also be 90 degrees. Okay. So now this angle here, it's in between the ladder, rope or the imaginary line and the line of sight. This is the angle of depression. So now you may notice a very interesting thing. So we are just going to assume that the ground is flat and the building's perpendicular. So you may know this. This is a concept from lines and angles, which I'll make a video about later. So basically, this angle is equal to this angle. I like to call these zangles or alternate angles. Zangles because they form a Z. See, if you notice it, it's a Z, it's a reverse Z. So this angle, this is also theta. So you can say that the angle of elevation is equal to the angle of depression if the line of sight and the ground are perpendicular to each other, which is true in most cases. Okay, so these are all the practical applications of trigonometry, and so there are many more concepts in trigonometry which we can go to in depth, but we let us also concentrate on some other topics. Right. So at the start of the video, I had told about how they determined Burj Khalifa's height using trigonometry. Okay. So they definitely couldn't have used a rope or ladder, since we know that the hypotenuse is always larger than the altitude. So that means they'll have to find a rope larger than 850 meters. And that would be a very inconvenient thing. So what they did, so they measured a distance from the ground in such a way that the angle or the angle of elevation was any angle. Like for example, it might have been 45 degrees. Okay, so if it was 45 degrees, it would mean that the angle of the Burj Khalifa and the distance they measured on the ground must be equal, since if one angle is equal to 45, another would be in a right angle triangle, correct? Okay, so now they measured this. So on the ground it's much easier to measure the amount of the length or the distance, isn't it? So they measured the distance on the ground, and accordingly they measured the height of the Burj Khalifa. So obviously I don't know the exact angle which they used. So if we just assume it's 45, so and if the Burj Khalifa is 850 meters tall, 850, so 850, right. So first they measured that the ground was actually 850 meters long with an angle of 45 degrees for angle of elevation. So that would mean that even Burj Khalifa is 850 meters long. Okay, and also one more thing. I told you that we use ladders also as the hypotenuse. You must be wondering why. Okay, so you must have noticed in your apartment or somewhere else, when the people are changing the light bulb in the lamp post, you might have noticed that they use ladders. But these ladders are never perpendicular. These ladders are never like this. They are always slanting to provide better grip. So the ladder is never perpendicular and therefore becomes the hypotenuse. Okay, thank you. So this concludes our video, and this is the fourth and final part of trigonometry. Okay, I hope you enjoyed the video and happy learning. All the best for your exams. Please leave any doubts, comments or any video suggestions for the next topic in the comments down below. And I'm also planning to extend this channel not only from maths but to do science as well, mainly physics and chemistry. So please leave your suggestions down below and I would really appreciate it. So go ahead, take a screenshot of this, it'll help you. Okay, thank you so much. Have a great day ahead.